The next design principle that we are going to talk about is the OpenClosed Principle. This principle states that classes should be open for extension but closed for modification. Let's go ahead and understand what this principle is trying to say. Let's focus first on the closed for modification bit. What that's trying to get across is that once you've written a class, it's done. You never should be adding anything to that class after that. No new member variables, no new member functions, no new interfaces implemented, no modifications, period. And why is that? The idea is that if you write your classes such that they are closed for modification, that implies that you're really putting in an incredible amount of thought into making sure that your classes are structured in ways that will be required both today and in the future. Now, a very reasonable response is likely to be that there is simply no way for a person writing a class to be able to anticipate all of the ways in which their class is going to be used. So it might seem like this idea of a class being closed for modification makes no sense at all. It would just lead to a bloat in the number of classes. We'd end up with tons of little classes doing very narrow little bits of work. But that's where the first bit of the design principle comes in. Those classes that are closed for modification can and should still be open for extension. And that means that it is theoretically possible for these classes to be used in a variety of ways that may never have been anticipated or imagined by the person writing the class. So what exactly does it mean for a class to be open for extension? Well, there are at least three distinct and important mechanisms that we can discuss whereby a class can be used by other classes or by other bits of code. And these are inheritance, delegation, and composition. Let's go through each one of these one by one and understand how a class might be open for extension via each of these three mechanisms. The first mechanism of extension is simply inheritance. If you write your code cleverly and if you structure your code such that it has plenty of abstract base classes, well, then others, either you or other clients, can find new ways to reuse those classes via inheritance. Those new classes would inherit from these abstract base classes and then plug in and add new functionality of their own. In that way, your classes, the abstract base classes, would continue to be closed for modification. Their bodies would not be changed. Simultaneously, those classes would now find new applications because they would be combined with the new functions that exist in the derived classes. A design pattern that makes perfect use of this principle is the template pattern. In the template pattern, there is an abstract base class which has a whole bunch of steps from an algorithm. Then, a whole bunch of derived classes exist, each of which implement a specific version of a particular step of that algorithm. In this way, the template pattern leads to code which is defined by classes which are indeed closed for modification and open for extension, exactly as the OpenClosed Principle would suggest that they ought to be. The next mechanism for implementing classes that are open for extension is delegation. If you write classes that fire events or expose properties, then other classes can listen in and take appropriate actions when something changes. This phenomenon or this mechanism is called delegation, and it's used very, very widely in a whole bunch of important programming paradigms and design patterns. The observer pattern, the model view controller paradigm, and also the chain of responsibility pattern, which is used in exception handling. All of these make use of delegation to ensure that classes, while remaining closed for modification, are still open for extension, just as the OpenClosed Principle would dictate that they should be. And the third important mechanism that can be used to ensure that classes are open for extension is composition. What is composition? Composition refers to a way in which you pass in member variables to determine the behavior of your classes. It's as simple as that. You have a member variable which is of type of some particular interface. The client code can then specify an implementation of that interface And then your code will use whatever is passed in, the memory variable that's passed in order to determine its own behavior. This is called composition. And a perfect example of this is the strategy pattern, and more broadly, dependency injection, which has become increasingly common and popular.